Hello, here we present the Text Cluster Explainer, a tool that allows users to interact with visual projections of text embeddings at scale. Users can automatically cluster the data and lasso a cluster to generate informative cluster explanations, insights, and further information about the data within the cluster. They can also use text projections to embed new data.
Concept Lens is designed for exploring generative models' latent space. It aims to unveil a structure of the latent space by presenting related semantic manipulations as clusters arranged in a hierarchy. Concept clusters are color-encoded to inform how much semantic change and how consistent those changes are, which allows users to understand both global and local behavior of the latent space.
Clouds play an important role in modulating Earth's climate. This makes them ideal for climate intervention techniques like marine cloud brightening or MCB. To facilitate the study of the possible effects and consequences of MCB, we have developed a hybrid AI-assisted visual analysis system to study the cloud-to-climate response function.
We present DataTales, a system that leverages large language models to help author data-driven articles. Given a chart, or a chart with specific annotations, DataTales creates a prompt including features from the input chart and annotations, and passes this prompt to the language model to generate both the text and a proposed title for the story.
We present Linguistic Lens, an interactive visualization tool for analyzing the diversity of datasets generated with LLMs. Large language models can be used to generate smaller datasets via few-shot prompting for benchmarking or fine-tuning. However, understanding and evaluating these datasets is still difficult. The failure modes of LLMs are not well understood. They can be repetitive not only semantically, but also syntactically and lexically.
Connect your smart device to WUDA to visualize rotations. Zoom and interact with the sphere to study the trace. You can even observe angles between the X, Y, and Z axes. For more advanced scenarios, you can transform your signal with quaternions. Notice the impact of rotating about an arbitrary axis.
We present ScatterUQ, an interactive scatterplot to visualize machine learning neural network uncertainty by comparing the proximities of test samples with training data. Here, the model is confident that this test sample is an ankle boot because it is nearby the other ankle boots from training. Here, the model is confused about this test sample because it is midway between shirts and t-shirts from training. Finally, the model thinks this test sample is out of distribution because it is distant from the training data.
Degree of interest functions underpin many well-known analysis techniques for large datasets like focus on context and information hiding, which bring out those parts of the data that are most relevant to the task. But what if the data is not available at once, but visualized progressively? In our paper, we demonstrate how regression trees can be used to efficiently maintain valid interest values in progressive visualization and also to prioritize interesting data in future chunks.